Hi, this video is going to cover functions, and specifically from section 3.5 and 3.6 in the Math 108, one of the Math 108 textbooks that I'm using. So the first thing that I want to make sure we define is when they say independent variable, what they're talking about. Some definitions. So independent variable is just your x values, and your dependent variable is y. So they say a lot of things about what's your dependent, what's your independent. You should know those ones. And then we should know what the idea of a function is. Like, what is the basic definition of this? What am I talking about? A function is a relation in which each value of the first set, there's exactly one value in a second set. So again, it is a relation in which for each value in the first set, there's exactly one value in the second set. I'm going to write that out. A relation in which for each value of the first set, there is exactly one value in the second set. Alright, so we're relating set 1 to set 2 by doing something to it. So okay, that's kind of a funky definition, or you're like probably a little confused. Think about a function key on a computer. What do? Well, you tell it something and it does it and you get an output. So you do an input and you get out an output. It's the same with math problems. You put in x values, you get out y values, or vice versa. So a function is just a way to relate these two sets. We happen to call that first set our domain, okay? And this is our x values, and our range, and this is our input. Our range is our y values or our output. And this is super important that you understand domain is x, range is y. What are you putting in? What are you putting out? This is what will confuse people the most. So you have this math problem and you have to figure out what you can put in. What can, without making the problem impossible or something like that. And then what can you get out? What is the possible output values? And that's your first set, second set. Let's see. So here's a couple examples. You might see points like this, and it might say, what's your domain? What's your range? Is this a function? Well, how do I know if something's a function? Well, the definition says that for each value that you put in, your input, your domain, there is exactly one output. Think about a math problem. Do you want there to be more than one solution? Or would you like to get the one solution? So you work really hard on this problem and there's two answers. That's hard. It's a harder problem. So what you look for is that the x values don't repeat themselves. This is a 1, a 3, a -2. We didn't see a second number 1. So each x value goes somewhere and is in a unique answer. So basically, this one is a function. And if I wanted to go even further, because it is a function, what's the domain? Well, the domain is going to be the set of values, because we have specific values of all the x's, 1, 3, and -2. Those were the values of x. What is going to be the range? What did we get out? We got out 2, 4, and 3. All right, so domain, range, x, y. Okay, so let's look at one that would not be a function in the points setting. So I just did 3 points to make it a little easier. I could have 50 points, and you just look at those x values. Look at this. I have a 1 going to a 3 and a 1 going to a 4. Do you want to put in 1 into a problem and possibly get 3 or 4? It makes it harder. And so it's not a function. Okay. And yes, there are problems where you get 2 answers, but it's not a function. So this is not a function. And sometimes they make you state the domain and range when it's not a function, but it doesn't make sense because domain and range have to do with functions, but the domain would only be 1 and 2. The range would be 3, 4, and 3 and 4 because there's 2 3s. Okay, so you'd only list the ones that you see. You don't have to push 3 twice. All right, so let's look if something's a function from a graph. We have a little bit of another thing to think about for deciding if a graph is a function. So we can look at points now. We've looked at that and we've decided if that's a function from a point standpoint. What if I have a graph like this? All right, so this is a parabola. You're going to graph a million of them at some point. So this is the shape of an x squared. Is this graph representing a problem that's a function? Is every x value you put in, does it give you a new unique y? So look at it and think about it. If I put in the number 1 and the 1 negative 1 here, don't I get out the same value? Does that make it not a function? Do you put in the number 1 and get out 2 values? Is there a place where you can find 2 values for one of the x's? So basically, we do something called the vertical line test. Think about it. Each x value needs a unique y, right? So if I did like an imaginary vertical line with this ruler, is there ever a place where I'm going to cross my shape twice? So watch the little green thing go across. It's only crossing in one place, vertically. Had I gone horizontally, which I don't, can you see that it would have crossed in 2 places? So when we look at this, we can think of the same idea as looking at the points, but we can look at it as a vertical line test. If it crosses in more than one place, not a function, but this one is. So let me draw something that's not a function so that you can kind of see. What if I had a similar shape, but it went the other way? Here's my x, here's my y. I know I didn't label super well, but think about it now. For our definition, if I put in the number 1, do I get just 1 spot on my graph like I did in the other one? No, I get 2. So not a function. So if there's any place that you could draw a vertical line and get 2 spots on your graph or more, you could get a million, it's not a function. So this one is not a function. And you know, I didn't say the domain and range on this one, and I really should. Maybe I'll come back and I'll do that in a second after discussing a little bit more with the graphs. What if I just have a graph of a line? Okay. It's hard to use this ruler in here. So here's a line randomly, x, y. Okay. So here's a graph of some random lines. You can just graph a line. Does this pass our vertical line test? Well, yeah, everywhere you go, right? One place, one place, one place. So all lines are functions, except if they're vertical. If it's a vertical line, it crosses every single, it's got a million points in common on the vertical line test. So like every single number will get you the same place. So vertical lines are not functions. All other lines are functions. Now let's go back and discuss domain and range of these graphs that we did. So domain, x values. What x values can I use on this one? Are they restricted? Well, these lines never quite look good when I draw them either. They kind of are going up and at an angle, but it's a very slight angle. So actually x is gradually getting larger and larger and larger. So there's not a bound. There's not a place where it stops, and on the negative or the positive. So for the x values, you could be way out here, you could be way out here. So the domain is all real values. So there's a couple ways I can say that. All real numbers, I guess. That's a better way to put it. So another way to state that in interval notation is I can go from negative infinity to infinity. Some use a fancy R. It kind of depends on, I just fell out of my chair almost. It kind of depends on your publisher. For Math 108 and the college type classes, they really do prefer interval notation, that you're understanding the lowest number is negative infinity and it goes to infinity. It's kind of an easier way to state all. Let's look at the range though. The range is restricted. This is a graph of an x squared, of a typical x squared. You actually cannot get negatives when you square something. So you can see that all the values are above 0 on the y. So you have to state that in your range. I'm only getting, here's my y, right? And the values, the graph starts above 0 and then keeps going forever. So the range is going to be restricted from 0 to infinity. And I actually just did this wrong. This should be a square bracket because you can be at 0, though it doesn't quite look like it on my graph, but I meant for it to be at 0. So the range was restricted on that one. Okay, so let's look at the domain and range of this one. The problem is I didn't label. So 1, 2, 3. We'll say that's -3, and that's the only one we really need to know. So x values, all right, are they restricted? Well, think about the graph beyond -3. Can you be over here? No, the graph is going to continue this way and this way. So the domain is going to be restricted on this one, and it's going to start at the lowest number you could be is -3, and you could be at that because the graph's at that point, and you could go to infinity. So this one was restricted from -3 and then on for my x values. What about your y values? These are going to gradually go up, although they don't really look like it. Like I said, they don't make a horizontal line. So that you can see that this would go up, 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 making the y values continue, and down is the same idea. This is going to go down, down, down. So the range is actually everything. All reals. It goes from negative infinity to infinity. All right. So domain and range. And what is the domain and range of any line? Anything linear. So linear comes up a lot. Well, what x values can you put in? I could put in any because this line would keep going. Same idea for y's, you can put in anything. So the domain and range is always all reals for both. So you go from negative infinity to infinity for domain and range on all linear equations. Okay, so then also let's look at well, they don't really talk about this in here, but I want you to know this. What is going to affect your domain from the standpoint of an equation? Okay, so just looking at an equation of something, what affects your domain and your range is going to be square roots, squares, things like square roots, right? You can't have negatives under the square root, so you have to, that's going to affect your domain. A square, I guess, affects your range because it gives you only positive answers that come out. Another thing to consider is that affects your domain is zeros in the denominator. So we're going to have problems with x's in the denominator in about, I don't know, a couple weeks, and that's going to affect your domain too. So there are things that affect your domain and range in your equations. That's the only ones I can think of. Zero in the denominator, square roots affect the domain. Range is affected by anything that affects the domain, but it's also affected by squares, or to the fourth or to the sixth, because those are all positive. Anyway, and we'll look at those more. Let's look at function notation. By now, you should have seen this somewhere, but we write f of x like this, and that's function notation, but it really is the same thing as y. So I interchange them. Sometimes I will be doing an f of x problem and I'll suddenly write a y, and vice versa. So I get really used to interchanging them and probably confuse my students. You have to understand those are the same thing. So if I give you something like this, all right, and why do I have this notation? Well, here's why. If I tell you, I'm going to put this one up here, f of x is going to equal x squared plus 3. So that's what I'm going to say f of x equals. So we know that's really y, but why do we use this notation? Well, we're talking about this input, output. That notation shows me input, output. So what I can see is maybe I'll see f of 1 equals what? What is that telling me? Well, it's saying input 1 for x and tell me what your answer will be. What will be y? So it's giving me my input, you have to find the output. So you'd put the 1 in for the x and you'd get 1 squared plus 3. Well, 1 squared is 1, 1 plus 3 is 4. So we really know that f of 1 is equal to 4. I can see input, output, x, y, all in one notation, which is super cool. If I have to graph that, I can now graph it because I see my values for x and y. So that's why we like this notation, and it follows domain, range, everything we've been doing. Okay, so what if I see, I'm trying to think, what if same problem, what if I just did f of negative 3? What am I saying then? You have to be careful with your negative. You're saying I'm squaring negative 3 plus 3. You have to write it like negative 3 squared plus 3. You have to think of it as the negative 3, the whole thing being squared. It's not 3 squared and then keep it negative. In other words, you probably put that in your calculator wrong and get it wrong because you used your calculator. Negative 3 times negative 3 is 9, right? So you'd have 9 plus 3. 9 plus 3 is 12. So if I put in negative 3, I get out 12. Input, output, domain, range. All right? And on this one, our domain will be anything, because I can put anything in and I won't get something that's not true. Like I won't get a negative under a radical. I'm not going to get a 0 in a denominator. So I can put anything in, but I'm restricted on what I get out because anything squared is positive. And actually the plus 3 will affect that too, because then you're 3 above 0. You're always going to be 3 above, you're going to be positive and above 3. Okay, so let's look at, what if I said something like this? What am I telling you when I say, all right, what is f of x plus 2 in this setting? Well, what I'm saying is, well, take x or x plus 2, excuse me, and put it into your function for x. So, oops, I should move that back down, I guess. I wanted a new paper, or maybe I'll just write it over here. Our function again was x squared plus 3. So if I'm saying I have f of x plus 2, you have to put that whole thing in right here. So the way that I think of that, and I'm going to have to, you'll have a kind of a big gap. The way that I think of doing that is wherever you have the x term in your function, I just put a parenthesis. So do you see that I took x out and I put a parenthesis? And I have to put in whatever input it wants me to, which is x plus 2. So this one's a little harder because it's telling you, okay, now put in x plus 2. And it makes you simplify that. Well, what is that? Well, this is the same thing as x plus 2 times x plus 2 plus 3. So this is the same thing as itself squared, right? So x times x is x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2 is 4. Still have my plus 3. Whew! Combine my like terms, right? If I went too fast, you can pause my video. Okay, 2x plus 2x is 4x. 4 plus 3 is 7. So I could reduce that all the way down to an x squared, an x, and a number. And remember, you can't add any of those together. So that they get a little harder is the point. Like, you can put in weird stuff and have to simplify the function. Why are they making you do this? They want you to understand you could input anything and get out anything, right? Or get out crazy stuff. This is how a computer works. I need to be able to input this and get this out. It's all that logical notation, or logical, thinking through something. Let's see. Yeah, okay. I'm just thinking what else I wanted to make sure I covered on this. Because I'm about done. Graphing. Well, so they give you things like f of x equals, I don't really care what it is, 2x minus 1. So this is linear. They'll give you something like this, and they're going to say, all right, graph that. Well, this isn't anything new. Isn't this the same thing as y? Well, yeah. So all you do is find a table of values that works for x and y, or f of x, and graph your line. So maybe I'll put in 0. 0 times 2 is 0. 0 minus 1 is negative 1. Maybe I'll put in 1. 1 times 2 is 2. 2 minus 1 is 1. Maybe I'll put in 2. 2 times 2 is 4. 4 minus 1 is 3. And now let me graph those. Let me draw a little graph over here. I like using a ruler because then it doesn't look so ugly. All right, x, y. So I have the point 0, negative 1, and I have the point 1, 1, and I have the point 2, 2, 3, 2, 3. And that better form a line. So really, the couple questions you have on functions and graphing, it should just be a reminder of the notation for one, and you should be able to then graph them. So let me do, oh, I know what else I wanted to do. I should have wrote down a couple more things because I was thinking, I have my notes, but I was thinking a couple more things I wanted to make sure I showed you. What if I have 2x minus y equals 7? And I'm told to put that in function notation. Well, we know function notation has the f of x, not the y. Well, I can't just put an f of an x in here. It's kind of weird, right? So you solve for y and then put the f of x in here. So like I'm going to minus the 2x over. So I have negative y still equals 7 minus 2x. So I kind of minused my 2x over. Oops, I didn't mean to make that mark. But I can't leave y negative. So then I'm going to divide each thing by negative 1 in order to get rid of that, or it changes all the signs. So it becomes y equals negative 7 plus 2x. Now that y is solved for, you can put in your f of x for y, and you're done. That's it. So what are they really making you folk remember? That y is f of x and you have to solve for y. So this is just like a repeat of solving for y on something, or solving for a variable on an equation. Let me give an example of what I was saying earlier too. I'm going to look at this. Oh, I put y instead of function notation. It's all right. I could have had, right, the f of x here or the function, the y. It doesn't matter either. So first of all, when I look at this, I have to decide if it's a function or not, and I have to decide domain and range. Well, we know the square root can't have a negative. So I cannot put in values that would form a negative. So what is my domain going to be? Well, the domain is going to be restricted. This has to be positive. So you find that by setting up that, 4x plus 2 has to be greater than or equal to 0. It could be 0, square root of 0, 0. That's fine. You just can't be below 0, right? So I just solve this equation. I minus the 2 over so that I get 4x is greater than or equal to negative 2. Divide by 4, and x is greater than or equal to negative 1/2. How would I state that in interval notation for my domain? Is I would say, okay, so you have to be greater than or equal to negative 1/2, so that I could equal that, so square bracket, and the lowest I could be is the negative 1/2, but I could go on forever, so the highest I would be is the infinity. So I restricted my domain, those are x values, to being positive. And how did I know that? Well, because I know a square root has to be positive. What about the range values? Are those restricted? Actually, I don't think it quite makes you do the range, but yeah, your range is going to be restricted because your x's are restricted, but right, yeah, because it would get, you can't ever get out a negative answer because you can't ever put a negative in. All right, so think about it this way. If I put in the lowest number I could, I was trying to think if you had to do this yet, but I don't care. Negative 1/2 times 4 is negative 2, plus 2 is 0. The lowest you could be is 0. The square root of 0 is 0. So the lowest y could ever be is 0. So your range is actually going to be, the lowest you could be is 0, but you could go up to infinity. Okay, so this one is, it could, see how the whole thing is under the square root? If I had like a plus number way outside of the square root, or I times by a number, then the range is a little different. But basically the range would have to be above 0 because you can't get the negative range out if you can't put the negative in the domain. So anytime the domain is restricted, like this one, then the range is probably restricted as well. Okay, so, and this one, how do we know if this is a function? Any value that I put in, I get a unique answer. I'm not going to get out two answers. I was trying to think of an easier way for you to think of that. But this is a function. You got a restricted values, but you got any number that you put in, right, is going to give you a unique answer. You can't put in the number 1 and get out, two different answers. You're going to get a unique answer. So this one is a function. I think that pretty much covers domain and range from a graph, what the domain and range are, the basic ideas of a function. So I think that's all I wanted to show you on this one. And this is for 3.5 and 3.6, and it kind of goes in all of it. And so if you have any questions on them, just let me know.